Hi, this is Mobile Computing Assignment 1. Here are our members. This video is to introduce the mobile edge computing. What is edge computing and why it matters? Edge computing is exactly what it sounds like. Computing that takes place at the edge of corporate networks, with edge defined as the place where end devices access the rest of the network. Things like phones, laptops, industry robots, and sensors. The edge used to be a place where these devices connected so they could deliver data and receive instructions and download software updates from a centrally located data center or the cloud. Now, with the explosion of the Internet of Things, that model has shortcomings. IoT devices gather so much data that the sheer volume requires larger and more expensive connections to data centers and the cloud. The nature of the work performed by those IoT devices is also creating a need for much faster connections between the data center or cloud and the devices. For example, if sensors in volumes at a petroleum refinery detect dangerously high pressure in the pipes, shutoffs are supposed to be triggered as soon as possible. With analysis of that pressure data taking place at remote processing centers, automatic shutoff instructions may come too late. But with processing power placed local to the end devices, latency is less and the round-trip time can be significantly reduced, potentially saving downtime, damage to property, and even lives. In other words, in order to migrate more ultra-low latency application scenarios to our network, we sync part of the computing and storage capabilities to the edge of the network and deploy servers closer to the demand. This is edge computing. The MEC architecture is shown in the figure. From the figure, we can see that these functional entities are grouped in the system level and host level. For the ME host level, the most important entity is the ME host. It provides computing, storage, and network resources for the system. It consists of the ME platform, virtualization infrastructure, and some ME applications. The VIM is responsible for managing the virtualized resources for the ME applications. Besides, the ME platform manager controls application instantiation and termination procedures, as well as providing indications to the ME orchestrator. The indication includes authorizations, traffic rules, and DNS configuration. Let's move to the ME system level. ME orchestrator is the central function, as it has a visibility over the resources and capabilities of the entire ME network. It contains the whole information on the system. From the orchestrator, there is a reference point toward the virtualization infrastructure manager, which is used to manage the virtualized resources of the ME host and to manage the application images that are provided for instantiation. Moreover, the orchestrator has a reference point with the operation support system that is intended for triggering the instantiation and termination of ME applications. The OSS receives requests to instantiate and terminate the ME applications from the customer-facing service portal and from the clients in the user equipment. Based on the above architecture, MEC can bring significant benefit to the mobile operators and common customers. Some applications are shown in the following part. First is about self-driving. MEC can be utilized to share information on road infrastructure, the position of pedestrians, other cars, animals, and weather conditions directly to the vehicles, instead of having to interface with the central cloud servers. Combining MEC with AI or ML will allow autonomous vehicles to be aware of their surrounding situations in real time. City is also welcome to use MEC, and here is an example. For optimal video surveillance quality, others bring innovation with an artificial intelligence solution, edge computer vision, which can be run in real time on a Sequana edge server. Edge computer vision automatically and seamlessly tracks individuals from one camera to another. The data is then collected, sorted, stored, and analyzed in Sequana edge server in real time and continuously. With both Sequana Edge and the Edge Computer Vision solution, servers can make decisions locally and in real time, process 4 times more video data than with an operator. increased responsiveness and accuracy. Next is about virtual reality, also known as VR. User uses a headset with a built-in screen that displays a virtual environment for you to explore and allows you to look around the environment by simply moving your head. In VR, the delay should be less than 30 milliseconds, when the computation and communication delay are mostly considered to meet satisfying experience. As you can see, comparing MEC with cloud computing, users' own tracking information and any relative data such as motions, positions are sent to server nearby, crossing shorter distance. Mobile edge computing pushes the computation resources towards network edge and neighboring end users, which cuts down the communication time. To reduce processing delay, MEC system utilizes the caches. Both MEC server and VR devices are applicable for computing and caching. MEC owns great amounts of computing and caching resources. With MEC implemented in VR, it will gain a fair latency which can be better than nowadays scenarios as shown in the table. Communication latency dropped from 40 milliseconds to 5 milliseconds, and computation latency from more than 100 milliseconds to 7 milliseconds, which is a very significant improvement. In conclusion, MEC has ultra-low latency, ultra-high bandwidth, and strong real-time performance. In general, the recurrent computing mode is an inevitable trend. From centralized computing in the mainframe era to distributed computing in personal computers to the current era of cloud computing, we are looking forward to the era of edge mobile computing. Thank you for watching.